Hi, I'm Zach Calhoun, and I'm going to show you three things today from Prop 29 of Euclid's Elements. The first one is that in this diagram, where our only given is that the line AB is equal to the line, parallel to the line CD. With that given, we're going to prove first that the angle AGH is equal to the angle GHD. So this one here and this one here. Second, that angle EGB is equal to the angle GHD. So this one here and this one here. And third, that these two angles taken together will be equal to two right angles. So to start with that, let's just start with the first one. So to show that AGH is equal to GHD, it will be helpful to do a reductio ad absurdum, which means that we'll be assuming just for the moment that they are not equal. So in that case, we can arbitrarily pick which one would be bigger. So in this case, let's say that AGH is larger than GHD. So in this one would be larger than this one. So let's see what happens from that. We can begin by adding the angle BGH to both sides. So this one right here. So now we have that this entire angle is greater than this angle plus this angle. So that's what we have here. But we know that angle AGH plus angle BGH are equal to two right angles. That comes from Prop 13 in Euclid's Elements. So that's here. And so therefore, because these two added together are greater than these two added together, that means that, let's see, that GHD plus BGH are less than two right angles. So that's the first part. But we have postulate 5, which is, in the beginning of the elements, Euclid claims that if two angles are less than two right angles, then eventually, keep going, they'll meet, right? That's the basic idea of the postulate. And so then, in this case, since these two angles right here are less than two right angles, then, well, AB and CD have to meet. But that's absurd because our given was that AB and CD are parallel. So that can't work. So therefore, our assumption that AGH is greater than GHD, which we could have just as well done the other way around, feel free to try it yourself at home, will show that, therefore, AGH must be equal to GHD, which is the first thing that we wanted to show. Cool. So now the next thing we want to show is that EGB is equal to GHD, right? So, well, we begin with the fact that AGH is equal to EGB, which they're vertical angles. So we know from Prop 15 of the elements, that these angles, that they're equal. And so we can very well say that, okay, AGH is equal to EGB, but we just showed that AGH is also equal to GHD. Therefore, these two are equal. So we have the fact that EGB is equal to GHD. Cool. So now we're on to the third part of the proof. We got this one. So now we want to show that these two angles here are equal to two right angles. We can do that pretty clearly because we can add BGH to both sides equivalently, in which case we have EGB plus BGH is then equal to GHD plus BGH. But for the same reason that we talked about earlier, just with a different line, EGB plus BGH must be equal to two right angles because they fall from the same straight line, from the line EF in this case. So therefore, since these are equal and this half is equal to two right angles, then we know clearly that by the transitive property, this side must also be equal to two right angles. So that's our third and final step. So we've shown these three things. So that's Prop 29 of Euclid's Elements.